Welcome to Math with Mrs. Bibb. Today we will be using formulas and doing some dimensional analysis. First, we want to define the word formula. A formula is an equation that expresses a relationship between certain quantities. A literal equation is a formula or equation. So a literal equation is another word for a formula that involves more than one variable. So we're going to solve for a specific variable. In this first example, we're going to solve for x. We're going to solve for x. I want to get rid of the minus 4m first, so I'm going to add 4m. This will seem quite strange to you at first. 5x equals 12 plus 4m. We cannot add those together because they're not like terms. And now I want to get x alone. How do I undo multiplying by 5? I divide by 5. So your answer is going to be an expression, not just a single number like we're used to when solving an equation. Our answer is x equals 12 plus 4m divided by 5. I have also seen it as x equals 12 over 5 plus 4m over 5. I don't write it this way unless both of these, this one and this one, are both reducible or divisible by 5. So I would leave it as the way I have it boxed. For the next example, I'm going to solve for m. But I want you to notice I have two m's. So when you have, I'll write this down, when you have two of one variable that you're solving for, I'm not going to write that. Put them on the same side. Oops. And undo the distributive property. Okay, so I am going to move the m's to the same side, and then I'm going to move the 12 to the other side with the minus 7p. I'm going to subtract 4m first. So I'm going to have negative 7p equals mn minus 4m plus 12. Then I'm going to move this 12 to the other side by subtracting 12. So negative 7p minus 12 is going to equal mn minus 4m. And now I have the terms that have an m in them on the same side. So I'm going to undo the distributive property. I'm going to put the m on the outside and undo. M times what would give me mn? And hopefully you know that that answer is n. And then m times what would give me negative 4m. And hopefully you know that answer is negative 4. Check yourself once you have done that. Make sure you're right. M times n is mn. m times negative 4 is negative 4m. So I have done that properly. And now I want to get m alone. How can I undo multiplying by n minus 4? I would divide by n minus 4. So m is going to equal negative 7p minus 12 divided by n minus 4. So this looks very, very strange, but that is my answer. I have solved for m. I have solved a literal equation for a specific variable. Example 3, I want to solve for k. I do have two k's. So let's do that. Let's move them to the same side. I'm going to add 4k to the other side. 5h is going to equal kn plus 4k minus 3. Then I'm going to add 3 to both sides. So 5h plus 3 is going to equal kn plus 4k. I'm going to undo the distributive property. I'm going to put k on the outside. What do I multiply by k by to get kn? Hopefully you see that's n. What do I multiply k by to get 4k? And hopefully you see that's positive 4. And now I want to undo multiplying by n plus 4, so I would divide by n plus 4. K is going to equal n plus, sorry about that, 5n plus 3 divided by n plus 4. And that's the answer to that example. Number 4, I want to solve for h. Now this one looks totally complicated, so let's do it very carefully. I am going to first get rid of this dividing by 2. How do I get rid of dividing by 2? I multiply both sides by 2. So 2 times a equals, this is the formula for area of a trapezoid, I'm pretty sure. And so I would have the height times the sum of the two bases. And now to get h alone, I'm going to divide by base 1 plus base 2. So I'm going to divide both sides by b sub 1 plus b sub 2. So h is going to equal 2 times the area divided by the sum of the two bases. And that would be my answer for getting h alone. For number 5, a mason jar company wants to increase the volume of its cylindrical jars by 6 cubic inches. The company's designer wants a formula that states the height h of a jar given by its volume and radius r. The volume of a cylindrical jar is modeled by the equation v equals pi r squared h. So I want to get h alone. Let's work that out. Pi r squared h. How do I get h alone? What's happening with h? H is being multiplied by r squared and pi. So to get rid of multiplying by r squared and pi, I would divide by pi r squared. So the height would equal the volume divided by the product of pi and r squared. So the height would equal the volume divided by the product of pi and r squared. So C would be the correct answer. And then for letter B, if the radius of the jar is 1.5 inches and the original volume is 30 cubic inches, then what height should the company make its new jar to increase the volume? By 6 inches. So if the original volume is 30 and I want to increase the volume by 6 inches, I would put 36 in place of the volume, and then pi, and then my radius is going to stay the same of 1.5 squared. With a calculator, I would do my denominator first. So I'm going to grab my calculator and I'm going to use the pi button, hopefully. Pi times 1.5 times 1.5. So I get 7 point, I don't really want to round, because if you round, you make that answer not be what it should be. I'm going to go out to here. That should make it okay. Then I'm going to divide 36 by that number. 8583. And I do get 5.09. Did it say what to round to? I don't see that, but 5.09295, so on and so forth. I'm going to round to the nearest hundredth. So I would have to have a height of 5.09 inches in order for the volume to increase by 6 cubic inches. The height should be 5.09 inches, or 5 9/100 inches, to increase the volume by 6 cubic inches. And I can't really see that, so hopefully you all can tell. You should write 6 cubic inches. I guess I could put it here. I don't know if you'll be able to see it all. Cubic inches. Dimensional analysis. Let's define what dimensional analysis is. It's also called unit analysis. It is the process of performing operations with units. Process of performing operations with units. And the first thing we're going to do is we're going to talk about Mark and a swimming pool. The salesperson says that the pool will hold 97,285 liters of water. If 1 gallon is 3.758 liters, 1 gallon is 3.785 liters. How many gallons will Mark's pool hold? Well, we would multiply 1 gallon over 3.785 liters by 97,285 liters. Now, this is why this is called dimensional analysis. When you multiply, I can put that over 1. When you multiply these two fractions, the dimensions of liters will be crossed out, and that would be 97,285 divided by 3.785 gallons. And of course, you'd have to have a calculator for this. I did not expect you to not do this with a calculator. And so when you type that into a calculator, 97,285 divided by 3.785, you're going to get approximately 25,703 gallons. So we will answer this in a complete sentence. Mark's pool will hold, approximately 25,703 gallons. That's dimensional analysis. For this example, there's a bunch of conversions that we need to do. We know that she bought a half a gallon of milk. A half a gallon of milk. So I've got to go from gallons to ounces. And it's going to take me a little while to get to those ounces. So a half a gallon, I know there's 4 quarts in 1 gallon. So these will go away. And then I've got to do a conversion with quarts. 2 pints are in 1 quart. So my quarts will go away. And then I got to do a conversion with pints. 2 cups in 1 pint. How did I know I needed to do a conversion with cups? Or excuse me, with pints, because pints was my unit left. Now I need to do a conversion with cups. 1 cup is 8 fluid ounces. See, I'm almost there. And so the cups will go away, and the unit that is left is fluid ounces. So I'm going to multiply 0.5 times 4 times 2 times 2 times 8. And that's going to be the number of fluid ounces. And if you do that math, you should get half of 4 is 2, 2 times 2 is 4, 4 times 2 is 8, and 8 times 8 is 64 fluid ounces. So that would be my answer. Nita has 64 ounces of milk. Well, that's really not my final answer. Nita has 64 ounces of milk. If the recipe takes 20 ounces, she can make it 3 times. 3 times 20 is 60. She'd have 4 ounces left over, but 3 times 20 is 60. This is my final answer. Pay no attention to this right here. I really don't need that circled. And the last one, in a novel, there's a main character, Aiko. Please forgive me. He can run long distances at 16.5 units per second. I don't know how to say that unit. Carla knows that the Olympic record for running a marathon distance of 26.2 miles is about 126.5 minutes. She wonders if Aiko could beat that record. If one of these units is 10 over 33 meters, how far can Aiko run in miles in that amount of time? Hint, 1 mile is approximately 1,609 and 344 thousandths meters. Okay, so we are going to convert from the unit of measure 16.5. I think I'm going to put a K. 16.5 K per 1 second. Then I'm going to convert. I know that 10 over 33 meters is one of those units. So now those units are gone. And then I know that 1 mile is 1,609.344 meters. And now my meters units are gone. And then I'm going to multiply 16.5 times 10 over 33 times 1 is 5 miles. In 1,609.344 seconds. And I want to know how much that time that would be in minutes. And so I'm going to convert that. I'm going to take 5 miles over 1,609.344 0.344 seconds. I'm going to multiply it by 60 seconds in 1 minute. And that will give me 300. My seconds units will cancel out. 300 miles in 1,609.344 minutes. So the next thing I would do is get ICO's rate in minutes, miles per minute, and the given time into the formula and simplify. So I'm going to take 300 miles, this is a lot, 300 miles over 1,609.344 minutes. And I'm going to multiply by 126.5 minutes. My minutes will cancel out. And that would equal, so if you multiply 300 times 126.5 and then divide that answer by 1,609.344, then you're going to get approximately 23.6 miles. So I know that according to this, ICO would not beat the Olympic runner because it looks like an M. He ran less miles, and I don't have room to write that. Maybe I can come up here. Because ICO ran less miles. 23.6 miles is how far ICO ran, and the marathon distance is 26.2 miles. So he would not beat that Olympic marathon record time.